The largest land animal alive today is the African elephant, about 6 tons. Impressive, right? Now meet Argentinosaurus, 70 tons. The length of 4 school buses. It walked this planet 90 million years ago. So here's the question nobody really answers. Why did dinosaurs get that insanely big? And why has nothing on land ever matched them since? The answer involves oxygen, hollow bones, and a biological trick so clever, it almost feels like cheating. Dinosaurs ruled Earth for about 165 million years. That's not a typo. Humans have existed for roughly 300,000 years. We are a rounding error, but size is the thing that blows people's minds. The biggest mammals today, elephants, rhinos, hippos, max out around 5 to 6 tons. The biggest dinosaurs were 10 to 15 times heavier. 3 questions are hiding inside this puzzle. 1. Why did dinosaurs get so big in the first place? 2. Why didn't mammals follow the same path? And 3. Here's the twist. Did gravity almost stop giant dinosaurs from existing at all? Let's go. First, let's talk about air, because the Mesozoic atmosphere was doing something unusual. Around 230 million years ago, when dinosaurs first appeared, oxygen levels were lower than today. That sounds like a disadvantage for growing big. But here's the twist. Dinosaurs evolved a breathing system so efficient, it gave them a massive edge over every other animal. Most animals, including us, breathe in, fill our lungs, breathe out, simple, but wasteful. At any moment, our lungs still hold stale. Used up air, dinosaurs, and their descendants, birds, evolved a flow-through breathing system using air sacs. Fresh air moves through the lungs continuously. Even during exhalation, no dead zones, no stale air. This made dinosaurs extraordinarily efficient at extracting oxygen. More oxygen means more energy. More energy means faster growth. Faster growth means, you guessed it, bigger bodies. This single biological upgrade is probably the most underrated reason dinosaurs could grow as large as they did. Now here's where it gets clever. You'd think a 70-ton animal would need enormous, dense, solid bones, but sauropod dinosaurs, the long-necked giants, had hollow bones. Not fragile, hollow. Structurally hollow, like scaffolding. Like modern aircraft wings. Their vertebrae were riddled with air pockets, sometimes up to 60% air by volume. This is the same system birds use today, which, by the way, are dinosaurs, technically. That pigeon on your windowsill is a feathered, miniaturized dinosaur. But that's a whole other video. For sauropods, hollow bones shaved off enormous amounts of weight without sacrificing structural strength. This allowed their necks to grow absurdly long, reaching food no other animal could access. Like eating at a restaurant with a permanent table on the top floor, while everyone else waits downstairs. Size became a feeding advantage. The bigger you were, the more exclusive your menu. Here's where things get genuinely weird. Some scientists asked a simple question. Did gravity almost prevent giant dinosaurs from existing? Basic physics says that when you double an animal's height, its weight increases by roughly 8 times because volume grows as a cube. But bone strength only scales as a square. So at some point, the legs should just snap. By the math, an animal the size of Argentinosaurus shouldn't be able to support its own weight on land, but they clearly did exist. So how? The answer: posture, bone geometry, and movement patterns. We're still figuring out. Sauropods likely kept their legs almost perfectly straight, like pillars, not like the bent knees of mammals. They probably moved slowly and deliberately, like living bridges distributing weight across a massive footprint. Some researchers even think they spent significant time in shallow water to offload weight. They didn't defeat physics, they negotiated with it. So if all these size advantages existed, why didn't mammals go just as big after the dinosaurs died out? Short answer: mammals got the wrong blueprint at the wrong time. When the asteroid hit 66 million years ago and wiped out non-avian dinosaurs, the surviving mammals were mostly small, burrowing, nocturnal animals. They survived because they were small, less food needed, easier to hide, but they carried mammal biology. Dense bones, inefficient tidal breathing, and a metabolism that burns calories fast. Warm-blooded mammals need a lot of food to maintain body temperature. Get too big, and feeding that body becomes a full-time crisis. The largest land mammal that ever lived was Parasauritherium, a hornless rhino relative from 30 million years ago. It reached about 20 tons. Impressive. But still only a third of the biggest dinosaurs. Mammals hit a size ceiling that dinosaurs had already broken through, using a completely different set of tools. So let's put it together. Dinosaurs became enormous, because of a combination of advantages that no land animal has had since. A breathing system that extracted oxygen with extraordinary efficiency, fueling rapid sustained growth. Lightweight hollow bones that let them build massive frames without collapsing under their own weight. And a structural solution to gravity. Straight pillar legs and slow movement that let physics take a back seat. Mammals inherited a different set of tools, not worse, just different. And those tools have a different ceiling. The age of giant dinosaurs is over. The asteroid saw to that. But the next time you see a bird, any bird, remember, you're looking at the last living dinosaur, scaled down, feathered up, mastered flight. They didn't go extinct. They just got smaller and took to the sky, which, honestly, might be the smarter move.